Alright, in this video we are going to use the Pythagorean theorem to solve some word problems. Obviously, using the Pythagorean theorem has been a pretty simple concept for most of you. So that's not the most difficult part when working through these word problems. The difficult part is going to be interpreting where the numbers should go based off of the information that they give us. I recommend, and I want you on every single problem to draw yourself a right triangle and figure out where and label the right triangle with the information that they're giving you. You are going to have to do that on your worksheet, so you need to do that in your notes as well. So number one says, find the length of a rectangle. So we're dealing with a rectangle that has a diagonal. So here's a diagonal of the rectangle that's 25 feet and a width that's 15. So the diagonal, the line we just drew through the middle, is going to be 25 feet. The width of the rectangle is going to be 15 feet. Notice when we made that diagonal, we actually made two different right triangles. So it technically doesn't matter if we put the 15 feet down here, 15 feet down here. We're going to be finding the same information for both rectangles. So if this is the diagonal and it's across from the 90-degree angle, that must make it C. That would make 15 one of the legs. So we're solving for a leg in this situation. Okay. So we set it up. 15 squared plus b squared is equal to 25 squared. And we solve it. So 15 squared is 225. 25 squared is 625. We have to subtract the 225 to get the b by itself, the b squared by itself. We get 400. To get the b by itself and get that exponent off, we have to square root both sides. So square root of 400 is 20, and of course it's a word problem, so we have to label it. So 20 feet. All right, number two says, a 20-foot ladder is leaned against a wall. If the base of the ladder is 8 feet from the wall, how high up the wall will the ladder reach? Okay, so a 20-foot ladder is leaned against a wall. So I'm going to draw myself a diagram. So here's a wall. Okay. So a 20-foot ladder is leaned against it. So if I lean a ladder against a wall, this is my ladder. It's leaning against a wall. They're telling me that that is 20 feet long. If the base of the ladder, well, the base means the bottom of it, right? So here's the ladder. Here's the bottom of it. So the base of the ladder is 8 feet from the wall. So here's the base. Here's the wall. They're telling me that's 8 feet away from each other. They want to know how high up on the wall, so will that ladder reach? So they want to know where is it at against the wall. So they want to know one of our legs. Because here's our 90-degree angle. On this one, I'm only going to set it up for you. You will need to solve it. So I will be looking for that answer when you show me your notes. Make sure you have it labeled correctly. All right, number three. Two sides of a right triangle are 6 and 10 inches. In part A, it says, find the missing side if these are the lengths of the legs. So they're telling me that 6 and 10 are the lengths of the legs. So that means if 6 and 10 are the lengths of the legs, I'm finding the hypotenuse. So 6 squared plus 10 squared is equal to c squared. Okay, and I'm just going to set it up because at this point we should be able to solve them all. Part B says, find the missing side if these are the lengths of a leg and a hypotenuse. So if I have the numbers 6 and 10, and one of them's a leg and one of them's a hypotenuse, we know that the hypotenuse is always got to be the biggest and longest side length. So out of these two, that would mean that the 10 has to be C, and 6 has to be one of the legs. So now we're solving for the other leg. All right, number 4. George rides his bike 9 miles south and then 12 miles east. If George wanted to go straight back to his starting point, how far will he have to bike? Okay, so here is his starting point. Hopefully we know a compass, so north, east, south, west. So if this is his starting point and he goes 9 miles south, so south is this direction, and how far did he go? 9 miles. He then went east, so east is going to the right, so east is this direction. He rode 12 miles east. He wants to go from that point straight back, so straight line, back to the starting point, and they want to know how far will that be. So that forms our right angle, so that means this, the distance back to the starting point, would be our hypotenuse. And 9 and 12 are our legs. All right, number 5. A rope is attached to the top of a 13-foot tall flagpole. The rope is fastened to the ground 6 feet from the pole. How long is the rope? Round to the nearest 10. So, flagpoles. So, flagpole. So a rope is attached to the top of a 13-foot tall flagpole. So this flagpole is 13 feet. Here's the rope attached to the top. The rope is fastened to the ground 6 feet from the pole. So here's the ground, right? 6 feet from the pole is where it's fastened to. So the rope is at the top and it's fastened to the ground right here. And this distance from the end of the rope to the flagpole is 6 feet. Here's our 90-degree angle. They want to know, if this is the rope, they want to know how long is it. So they want to know C. So 6 is one of our legs. 13 is the other one, and we're trying to find the hypotenuse. So when you bring me your notes, I am looking for the correct answer, rounding included, for these problems that I helped you set up in your notes, okay? Because we should be able to solve them at this point on our own. So I'm looking for the correct answer in terms of our notes before you can start on the worksheet.